I'm Brian Johnson. I earned my PhD last year in August. My background was primarily with relatives of smallpox and monkeypox virus. So I've been researching primarily viruses, and then I've been teaching at the community college. A really common theme in germ warfare movies is the idea of we want a virus that will kill 100% of the population and do it quickly. I have a hard time imagining using germs effectively because if you're killing people really quickly, it's very hard for it to spread outwards. It's one of the reasons why Ebola is, a terrible disease, but outside of the outbreak a few years ago, when you had a more persistent infection, it's generally a very quick disease. It infects people, a bunch of people locally die, but then it can't spread any further. If you have this virus that's more or less at equilibrium with the animals, these animals are carriers of the virus and they're fine. Even if it wipes out all the humans, it's still in those animals, so it can come back again. Ebola usually starts with a bat or some animal infecting a human. And now because that virus hasn't had any reason to learn to play nice with humans, it just wipes them out and it's over. You can either be very lethal and take a while, or not as lethal and be very quick. And so I think a good flip side example of this is the slides I had about HIV. So we have a polio vaccine, we have a smallpox vaccine, but we don't have an HIV vaccine. And that's because HIV is very good at mutating and having a very broad differing population, so that even though your body's trying to fight it, it'll mutate away and escape. Just to give an idea of how complicated HIV is, this is the diversity of flu in the entire world in 1996. So what they did is they took flu samples from around the world and they did some DNA sequencing. And they put together this figure, this little tree showing, okay, this is how similar all the flu in the world is. That is the diversity of HIV in a single person. That's HIV in one city. That's HIV in one country. So that's kind of the scale of the problem trying to develop a vaccine. So HIV is devastating and very difficult to deal with, but people are still finding good from it. And that's because HIV and its relatives, their superpower is they can get into the brain of the cell. So cells hide their instructions in the nucleus to protect them. HIV is one of the few viruses that can get into the nucleus to change the DNA directly. And so this is really bad when it's making us sick, but this also means that we could potentially use this to fix problems in DNA. In some ways, the ideal offensive virus would be something, I think, with a long invisible period where you can get on a plane without there causing issues. You have no idea it's there until, oh no, it's too late and it's already spread really far. It's silent killers like that which take a long time. I think those are the ones that are really scary. Ebola has, it's not as long lasting. People might be boarding the plane fine, but you can tell pretty quickly. Using it for conventional warfare, at least with those parameters, 100% dead. If you were wanting to wipe out a small community, maybe, but it's hard to imagine something working that quickly and not burning itself out.